Hi there, this is Miss Heaton signing in to talk with you about formulas of hydrates. Let's first define what that word formula of a hydrate means. Well, if you're well hydrated, that means you've probably consumed a lot of water. Well, the same thing is true for ionic compounds. They can either be hydrated, meaning like if you had NaCl, it'd be an NaCl with a bunch of H2O water molecules attached, maybe 2, maybe 3, maybe more, but they're all kind of attached to the sodium chloride. On the other hand, anhydrous or anhydrate would just be the NaCl, the ionic compound with no waters attached. In this topic, what you need to be able to do is figure out the formula of a hydrate if I give you some experimental data. So let's try an example problem that looks familiar from your worksheet perhaps. Let's say that the hydrate of magnesium sulfate has a mass of 13.52 grams. So when it's attached to waters, it weighs 13.52. If you heat it up and evaporate the water, the anhydrate of magnesium sulfate weighs only 6.6 grams. So the first step is to find how much water evaporated. Well, that should be easy, right? Because if you had 13.52 grams and 6.60 was left after you evaporated all the water, the difference between those two numbers, which is 6.92 grams, would be how much water had been in your hydrated form. Then what we want to do is find the moles of just the ionic compound, in this case magnesium sulfate, the anhydrous, and then the moles of water, which we can get from this number, and compare those. So to do that, we're going to go from grams to moles using the molar mass. So in this case, our ionic compound is magnesium sulfate, so let's find its molar mass. So let's see, magnesium weighs 24, oh yeah, you're definitely going to need a periodic table. 24.3 grams for the magnesium, sulfur weighs 32.1, and each of the 4 oxygens weighs 16. So the molar mass of this compound is 120.4 grams per mole. But we have, let's see, 6.6 grams of the anhydrous magnesium sulfate. So let's figure out how many moles that is. Well, if you've got this many grams and 1 mole weighs 120.4 grams, then we can use factor label to figure out how many moles of magnesium sulfate we have. So you divide those and you get 0.0548. And that would be moles of MgSO4. We'll do the same kind of procedure with our amount of water to find the mass of water that was in our hydrated form. So this will be 6.92 grams of water, and the molar mass of water is 16.0 plus 1.0 plus 1.0, so that's 18.0 grams for every 1 mole of water. So using dimensional analysis or factor label, that turns out to be 0.384 moles of H2O. So you can see that this is kind of like an empirical molecular formula problem in that you take the mass and you convert it to moles. Now what we're going to do is compare those two. We're going to divide by the smaller of the two to figure out the ratio between moles of water and moles of magnesium sulfate. So like we saw in our sodium chloride example, are there 3 waters for every sodium chloride? Or for our magnesium sulfate problem that we're trying here, how many waters are there? So we'll just take our bigger number, the moles of water, and divide it by the smaller number, the moles of magnesium sulfate. And we want to compare moles to moles because masses do not tell us anything about the particles. And when you divide that, you get 7. What that means is that there's 7 waters for every 1 MgSO4. So the way to write the formula, our final step, would be to write it as MgSO4 dot 7H2O. And this is just the convention we use, where we write the ionic compound and then a dot and then 7 waters, or however many waters there are in the compound. And you don't need to worry about writing the name, even though the problem says to do that. All I care about is that you can do this part right here. So folks, that is formulas of hydrates in a nutshell. Happy practicing! Miss Heaton, signing out.